I am here with Jonathon Curl from Robotis. Jonathan, you are an expert in the field. Now, you say technician, robotics technician, but you're an expert in the field.
I am, yes.
Please, let's not walk on eggshells. Thank you for taking the time to join me today.
Thank you. I appreciate being here to talk to you, talk to your fans.
I'm so, look, we've talked offline, and I am so into the whole world of robotics and animatronics, but I actually wanted to talk to you today about AI in the physical world, because AI has become such a hot topic, such a trend, and obviously it's more than a trend. But the folks at Robotis, you folks are doing some really fascinating stuff. So let's just get right to it. Talk to me about what you're doing with MIT.
Yeah, sure. So for MIT, with them, maybe the specifics are still under wraps, you know, how stuff like that at that level can get. But we're basically working with them to enhance the precision specifically in physical AI of manipulation. Because one of the things that like a hard goal for robotics at this stage right now is to be able to pick things up and interact with them the way we do as humans, right? It's a lot harder of a problem than it looks like. And one of the big barriers there is you need something that looks roughly like a human hand and acts roughly like a human hand while still being able to convey the relevant information on grasping to the controller. Because when we handle something, we don't think about the fact that we know how hard we're gripping it. We know how well it's adhering to our hands. We know roughly how much, friction we have to keep things from sliding out. You know what the difference between grabbing, a slippery, wet, smooth thing versus like a stone with some jagged edges. You know how much grip you have. A robot doesn't really have that. So that's kind of what we're working on. We're working with MIT on ways to make sure that the robot can get all of that information while still being able to grasp and hold things in a meaningful way.
Well, you're really talking about the nuance. Obviously, open and close is something animatronics can do, base level robotics can do. You're talking about something that literally can think and respond according to what it's touching, what it's moving.
Yeah, that's sort of the natural progression of robotics. As you mentioned, AI is becoming a huge thing in every aspect of life. All of us are pretty familiar with the concept of generative AI now, right? Where we can hook up a robot and tell it, I want you to make this thing, this art, this music, this writing, this ad copy, whatever, right? And that's, it's not a solved problem, but it's not really that hard to get an AI to generate data in a digital space. But the hard part is getting an AI to bridge that gap into the physical world and manipulate real physical objects. There's a lot of stuff that we as humans have to do to interact with the world that we don't think about. And having a robot understand what that is where AI is going now. And these two things are actually pretty closely intertwined because one of the sort of difficult parts about teaching these robots how to do these things is you need a lot of data. And to do data like what we're working with MIT, the data we need for that, you need to manipulate objects, right? You need to pick up 100 cans before the robot can even get an idea of what a can is. But you can't do that for every object on Earth. That would be millions and millions and millions and millions of hours of picking up cans or whatever. But generative AI, that's what AI is good at already, making videos of people picking up cans. So marrying the two together is going to be the way we're moving forward in this space because we can create huge amounts of data. We can create a base set by actually physically doing the thing. And then we train a robot on that base set to say, hey, what does this look like if we do it 10 million times instead of 1 million? And then we then take that data and feed it back into the robot to say, can you pick up this can?
It's fascinating to me because you're filling in all the gaps, and that's where AI is a tool set, not a replacement.
Yeah, and that's kind of one of the things about people are scared of AI, right? Because it sounds scary. Robots are doing things, replacing humans, stuff like that. But we're nowhere near that. I guess sort of the important thing that I have to talk to friends and family when they ask what I do, and they're like, "Oh, our robots going to be replacing us anytime soon?" The robots are a lot dumber than you think they are, because there's a lot of things that go into even the simplest job, simplest action. There's so much that we as humans know that enable us to work in the world in a real meaningful way.
Well, I listen. I don't even want to bring this up, but I know people out there are thinking of Elon Musk's quote unquote AI robots, which were not truly autonomous. And I think that's where the scare factor comes from. What you're talking about with MIT, at least at the base level, if somebody were to go Google an article, they'll see something that reminds them of Jarvis from Iron Man, like a robotic arm. My question for you is, and it looks to me, and correct me if I'm wrong, this is actually backed by South Korea. I'm trying to figure out what the end game is. What is the larger implementation into beyond entertainment? Because people could say, oh, you could do some really fun stuff in theme park. Great. And beyond assembly line manufacturing, where does this really enter our everyday lives? Because I think of the Internet of Things, and to me, physical AI is akin to the Internet of Things for AI.
I guess it kind of is. It's not necessarily physical AI isn't really like one thing. It's this big umbrella collection of here is all the things we can do when we teach robots how to exist in the real world. And for the specific, MIT research project, since it's entirely for research, the end goal of that in particular is to work with us to basically develop that hand I was telling you about, so that other people who are building robots, now they don't have to solve the problem of how can I get my robot to touch things. That's solved, and they can focus on what they actually want that robot to do, what they want it to move. They can focus on training it to interact with the thing they want to interact with in the way they want it to be done.
I mean, you're really operating, 10 years out then with something like that in terms of who's going to come along and actually take that foundation and run with it and develop it into something?
That's really what high-end robotics research ends up being. You're sort of throwing stuff at the wall.
Sure.
And the reason you always hear about, you hear about these amazing breakthroughs, new materials, new technology or whatever, and then you're like, why isn't everything made with that? Because in maybe 10 or 15 years, once we figure out how to make a lot of them and make them reliable, it will. But high-end robotics research is a lot of, you try things and maybe it turns out this isn't the best solution to the problem, but you learn something valuable that you then can be applied in a practical way later, which kind of comes back around to the humanoid robots that people are talking about, interested for, excited for, scared of. That in itself is sort of a stopgap solution. I mean, human bodies aren't the best way to do a lot of things in manufacturing or whatever. We're not super efficiently designed, but the world is designed for us because we built it. So right now, that's why everybody's so excited about making humanoid robots, because then if we make a humanoid robot, we can just put it in a dangerous situation where we would normally send a human and do it the way the human would. But that's going to be a good solution for, the next 5-10 years. But then in 20 years, when we're building the new factories, why would we build them for humans? Just make the whole building a big robot, right? That's a lot easier, a lot better. It's going to be faster, safer, cheaper. So even stuff like this, like humanoid robots, is in itself a stopgap solution for planning something 10, 15 years out.
Yeah, no, it's fascinating to think of it in those terms. The arm that we keep calling the arm is open manipulator?
Yes, the open manipulator, it's a sort of an umbrella term. We have different sizes made out of, we make a lot of different sizes of motors. So we have an open manipulator for every size.
And the way you described that a moment ago, I'm still thinking about that. The idea of, okay, I can have it pick up a can, but now how do I have it pick up every object in the world without having it pick up every object in the world? I was thinking earlier today about the early days of voice recognition. I think it was like Dragon Speak or something, and you would have to talk into it and read it several paragraphs to get your voice and your tone so that it could then do voice to text. And now
Move fast.
And now when we're done this today, I'll have a full transcription of this entire interview before I can even upload it.
Yeah, that's underselling it. You probably already have a full transcription as we're recording.
I just can't get to it because I'm too busy talking to you. And it's like Spaceballs. When will them be now? You know?
It's amazing the things we're working on. Like, I occasionally see new developments before they really hit the market, and it's wild what technology is doing even a couple of months ahead, right? Things are moving so fast right now. In the next 2 or 3 years, our concept of what robots are and what they can do will change significantly.
Now, are you involved in the NVIDIA project, the Jetson Thor project? Do you know about that?
Not directly,
Okay.
But it is something on our end, we're making sure we have a lot of robots that are currently on the market and will be soon. And we're working with NVIDIA I can't really disclose too much specifics, but basically to make sure that their hardware works with our hardware in the best possible way.
Well, that's what I was getting to, was market standardization. I'm an arcade guy, okay? So I remember I was too young to remember when it happened in real time, but I think of the JAMA standard, right? And how it's...
I'm not familiar with that. Could you...
Yeah, what's your favorite arcade game?
Simpsons Arcade.
Okay, so The Simpsons is a Konami game. There's actually, you can do 2 different ROM chips on that. You can do the 2-player or the 4-player. But a Simpsons game is JAMA, and JAMA is the arcade standard. Anything pre-JAMA would have been a dedicated machine. Because The Simpsons is JAMA, I can very easily just pop that board out and put in an X-Men or a Ninja Turtles. And because it's the same exact wiring and the same harness for the additional players, if I'm an operator, now I don't have to go back to zero. It's essentially, the quickest possible conversion kit.
And I remember reading a while ago that there's like a big issue with preservation of old arcade machines because, like you mentioned previously, everything was built to do one specific job, right?
Mm-hmm.
Right now, we're at that stage with robotics. We're still trying to figure out how to do all these jobs. And early robots, some of them are going to be dead ends. Some of them are going to be like, hey, we want to keep this thing. And then some of them are going to be, that's the future. And then eventually we will come up with this standardization. NVIDIA is already backing a lot of sort of AI-focused methods of that as far as control, interaction. There are other companies that I'm not even sure I can name that I know are working on even more comprehensive solutions, like plug-and-play brains for all kinds of robots.
But are they adhering to the same market standards that you might? And I know you can't necessarily answer all of this, but my thought is, are they adhering to the same standards you might be trying to enact with NVIDIA?
And that's kind of what's going on. That's certainly something I can speak to.
It's like beta and VHS.
That right now we're still in that beta versus VHS versus Laserdisc. Like people are still championing their particular solution,
so cool,
fighting against others. And it's an interesting space because since I mentioned the data and how we need huge, vast quantities of it, right now, all of these competing companies, they're working really hard on standardizing the data because more data is good for everybody, right?
Right.
But they also want to make sure that once everybody has enough data, they know that then they're going to be directly competing against each other instead of cooperating. So they're also developing their own standards for not just the data, but for interoperation with actual hardware. So right now, everybody's really focused on working together to make sure that the foundation is as good as possible. And then the next 3-4 years, we're going to have that moment where everybody releases their, Blu-ray, DVD, Betamax in the next couple of years, and that's when things are going to get really exciting.
That makes me think of the early days of DRM. So it's like, you do something till it's good. So you'll be essentially open source until at some point everybody's so competitive, now you want to close it off.
Yeah,
and
you have to specify, you have to pick your lane, basically.
Do you think that when we get to the point of, 10 years from now, okay, let me just pump the brakes for a second. I'm thinking about all these wildfires in California and rebuilding and stuff like that. And do you think like in 10 years time, there'll be enough implementation of physical AI where not only can we help in these rebuilding efforts in a situation like what's going on in California, and I know you're out there, and I hope you and yours are doing okay, but also in responding to it. I mean, you made a comment earlier that made me think about that too, is you could send physical AI into situations and really mitigate risk.
Yeah, well, I mean, sort of to point to that, I hate to bring the vibe down a little bit,
But it's real talk.
Yeah, but the edge of technology in robotics, especially, is in super hazardous environments like that. With what's going on over in Ukraine, it's huge for robotics because they're putting robots in difficult conditions where environment variables are unpredictable and unknown, and they're seeing, are they working? Like, is this working? And in 10 years, not even in 10 years, in 5 years, that's going to be common in places like that, in conflict zones, things like that. And then another 5 years past that, once it's cheap enough that cities can start affording them instead of countries,
right,
we're going to start seeing them in disaster scenarios and places like that because it's the easiest way to save lives, right? To not have to send more people in there.
Yeah, well, and I can see, I mean, it's logical that the military funding would pay for the innovation or at least help subsidize it to get to the point where it could actually be more affordable. I mean, somebody's got to foot the bill.
Yeah, and I mean, we throw money at it, so they're going to solve the problem, make it hopefully cheap enough that other people will be able to use it.
Yeah, I'm fascinated by how early. I mean, that's why I specifically wanted to talk to you about physical AI because that is so early. From the front-facing consumer perspective, I don't even think people even know what that is. And I was like, oh, this would be a great opportunity to start our conversation. And then I start to geek out over the idea of being early on the standards because I would imagine the market's learned so much from just the history of technology and how many times the failure to standardize early has thwarted innovation or, just made it bad for business.
Yeah, and like one of the conversations that I'm constantly having, I guess to get back to that point with the AI companies that we're working with, is we haven't even really decided on what a robot arm should look like, what the standard robot arm is. We're still trying to decide, do we want 7 joints, 6 joints, 5 joints? Where should they be? We still haven't even figured out that. And that, on the surface, it sounds like such a basic concept, right? Like an arm just needs 2 or 3 joints, right? But even that has such a huge effect on what a platform is capable of, the kind of motions it can make, what it can safely do. And we haven't figured that out yet.
Well, if you're talking about an arm that at some point would be capable of helping in surgery, that's got to be micro precision. That's not going to happen with just pulses. It's got to be a lot more thought.
Mm-hmm. And then when we're talking about the standardization, the thing about that is we want, in order to have the best grounding for the most robust AI system, it helps a lot if all of the arms from that micro precision arm all the way up to the huge, lifting cars, if they have the same basic configuration so that we can apply the same general, algorithms and things to make the motions as good as possible, because that just means more data. And we haven't figured out what the standard arm idea should be yet.
But yet you have a lot of things implemented in the real world already. So you have a lot of case studies, and it's just a matter of, it's literally you're throwing stuff against the wall.
Yep. If we put the joints here, it turns out it can't move in this particular direction at this speed. Or if we, put these joints opposite directions, they sometimes collide during motions like this, which happen a lot. So things like that. We're running into small problems all over the place.
Can you talk a little bit about where some of that stuff may be implemented that people would recognize or at least understand?
Yeah. So, I mean, like the most common application for robotic arms in specific right now is in manufacturing, like material handling, simple, a bunch of parts come down a line and then you pick them up, inspect them, and put them wherever they need to go. Sort of the problem is that for every different configuration of arm, especially with different joint lengths, different orientations, is that there's going to be a limitation on how close the arm can get to its base and how far it can extend, as well as there are going to be sort of weird dead zones where, based on the different joint configurations of each space, either the robot can't reach that position, or there are sort of invalid ways to reach that. Like the robot thinks it can get there, but actually, based on its own weight, the self intersections, things like that, it looks like it should be able to arrive there, but it can't. And we're still running into a lot of problems like that that can't be solved at all scales and all sizes, but we still need to figure out a way to apply the back end information of here is how you make motions like this to as many different systems as possible.
Right.
Because even if we want to standardize robotics, there's always going to be some amount of individualization, because that's how you increase efficiency, and that is the ultimate goal of automation in general, right?
So is your business to business stuff all, I mean, it's all got to be, everything is just individualized and customized. I mean, there's no just off the shelf, right?
Yeah, our specific, that's how most motor manufacturers and things deal. Everything is built for a specific purpose, but our like sort of tack approaching this is like a weird middle ground. You know how I mentioned previously the open media player, how we have one for each different size of motor? The way we sort of deal with business customers is we say, hey, we're here to work with you, and we have, these brackets of capabilities. And then depending on your budget, what you need and the specifics of your application, we can work with you in this sort of bucket of capabilities so that we can have something that is tailored to you, but you don't have to go through the whole fine-tuning development process, because that's when prices skyrocket, right?
So it's like semi-modular in the sense that
modularity, customized, built to suit,
right,
rather than built for purpose, I guess is.
So you sort of like pick your sandbox.
Yeah, this is generally where we want to be, and then work within that space. And then sometimes you might need to move up, sometimes you might need to move down. But the important part is to make it so that it's adjustable without having to make everything bespoke.
And you guys are involved in so many different things as a company, and I'm obviously interested in talking to you primarily about physical AI. But just to have a little fun for a second, I mean, you are in the theme parks and you are in gaming, and I'm fascinated by transportation. That's actually what I want to get to in a minute. But I mean, you are everywhere.
Yes, we are. I am consistently surprised when, every 2 or 3 months, a company I've never heard of reaches out to me and is like, hey, we are currently using your parts in this thing that exists that I've already used. And I'm like, I didn't expect that. Or, I'm constantly getting emails from people, since we're in the LA area.
Sure.
We do a lot of support for the film industry. And, I'll get emails from special effects designers, and they're like, hey, we're working on this part for this movie. And I'm like, wow, that's really cool. Like,
and you don't even know that until somebody tells you, because you have so much business coming in from different areas, you can't even necessarily tell who's doing what.
Yep. I have my people that I'm familiar with that I work with on a daily basis, but that's only a small part of, we're everywhere.
Yeah, it's a huge company. How many offices does Robotis have worldwide?
I believe we have 5, each one in a different continent.
And are they all working on different things, or is everybody cross-pollinated?
A little mixture of both.
Okay.
And then they all have different specializations. Like our Japan office in specific is very heavily focused in R&D. Our headquarters, obviously, product development, stuff like that. Like they each have a little bit of a flavor to us.
Where's the Japan office?
I believe it's in Kyoto.
All right, listen, next time I go to Japan, I'm going to request a tour.
I'll let our boss know.
The standard of quality in Japan, have you been to Japan?
I have not. I've wanted to go, though.
It is, well, I'm sure you'll appreciate this. The standard of quality over there, and obviously I'm a Disney guy, so I spent some time in the parks, considerable time in the parks, and you can see the difference there. But just even going into the city, it is just night and day. The kind of things that would sit not working here. Just to be a real geek for a minute, they had a coffee vending machine that like serves the cup and puts the ice in and does it. And I was loving this thing, and then it broke. And I came back a few hours later and it was fixed. And I was like, in America, this will be down for a month, if not two.
Yeah, well, the town that I grew up in is West Covina. It was featured in a television show a couple of years ago, Crazy Ex-Girlfriend. We have at outside of our movie theater a fountain. It worked for 2 years when I was a kid, broke, never fixed. They fixed it for filming the pilot episode of that television show. It worked for a month, broke, still hasn't been fixed.
Part of it is a lack of desire, and I think part of it is just people aren't educated. And I hate to say that, but I don't know if we're doing enough in our schools to introduce kids to this stuff. I as a Disney geek am just fascinated by the idea of progress and innovation and breaking new ground, and what Walt accomplished with animatronics and so many other things, and transportation, which I'll get to in a minute. But I feel like we aren't, like, what we're talking about with physical AI. It sounds really crazy, but when you tell me that we're really 10 years out from it being something that would be implemented in the average person's daily life, that means we still have time to educate a domestic workforce so that we can actually be leading in this market and not be losing to other countries. And I know there's room for everyone, but it's not that heady. When you tell me that you're throwing stuff against the wall, I think that alone should be make it accessible for anyone.
Yeah, and right now it really is. I mean, that's one of the cool things about, especially with AI in specific, since such a huge part of it is digital, right? Even the most powerful AI fundamentally exists in a way that is meant to be decentralized. So there are huge companies. Hugging Face is a partner of ours that we work with relatively frequently, and they released a robotic arm kit specifically designed for training AI that's under $200 so that anyone can do it anywhere in the world. And that's where we are right now, that literally anybody who has any amount of interest, they can learn a new skill, contribute something meaningfully to the advancement of not just current technology, but honestly, humanity as a whole. This is a big thing we're working on. And
it's a lot more exciting than just throwing command prompts into ChatGPT and seeing what you get.
Yeah, and it's a lot more exciting. It's easier to get started with. It's more fun. You get to actually, physical objects, move things around. It's great.
I'm trying to kind of be as cohesive here as possible, but I get naturally excited about the subject, so then it makes me think of things. But I do want to talk about transportation. Talk to me about where the long-term benefits of physical AI would benefit transportation, whether we're talking public transportation or we're talking, cars, whatever it may be.
I mean, there's so many ways you can talk about how this, what I think makes the most sense is public transportation is going to get so much more efficient. When all of a sudden you don't have to hire bus drivers, you have options like, basically an automated train or something goes around, picks people up at stops, on-demand calls for shuttles, things like that. It's going to be so much more efficient. You don't have to wait nearly as long because you can have individual service to different places. It's going to be a lot safer. I remember reading an article 2 or 3 years ago when the concept of driverless cars was just starting to take off, where that doctors in like the medical community were getting actually legitimately concerned that once autonomous driving becomes the standard, we're going to run out of organ donors. And like, that sounds really weird to think about.
That's a wild thing to say.
Yeah, that's a high cost, unfortunately. That's a thing that happens a lot.
Right.
And then that saves lives. But when that source dries up, what do we do then? Yeah. And that's many, many things.
I shouldn't say this, but you program that in.
We're just going to give it a 2% failure rate for humans.
Horrible. But, look, a little humor, right? A little humor. I'm thinking about the difference between, because you just talked about a driverless train. What's the difference between the implementation of physical AI in a train and in a driverless train versus just automation?
I mean, the big difference between like sort of the umbrella concepts of like physical AI and like general automation is that in automation, which is it's the industry standard right now, it's not so much you tell the robot, I would like you to do, in the case of a train, it's not saying I want you to drive from St. Louis to, wherever, right? Instead, automation right now is saying I need you to move this distance at this speed and then turn here, and then this distance at this speed, turn this many degrees. You're specifying exactly the actions you want the robot to take. You're just saying, here's the recipe, do that. And physical AI is being able to instead tell the robot, I need you to get from point A to point B, and letting the robot figure out how to do that. And sort of the big holdup is that in order for the instruction, I need you to get from point A to point B, to be meaningful to a robot, there's a lot of information about the world that you need to teach it.
Well, and I guess it's also the difference in automation is that it would be purely it's a linear thing, right? Like I'm getting you from point A to point B, and if something gets in the way, automation doesn't know how to respond, whereas AI would.
At best case, you'll have some sort of backup system where it'll stop safely, and worst case, it'll just keep doing what it's doing and make things worse.
And I'm thinking, oh, that's fantastic. You think of like the New York City subways and lives would be saved. And then you're telling me about cars. And so it's a double, like anything else in this world, it's a double-edged sword. You would think that the benefit of all of this would be that you would be reducing risk and saving lives. But the idea that and that's crazy.
Parts of our system rely on things going the way they are.
Well, that'll open up another market, though. That's what's fascinating about that. So then that will be a problem for somebody else to solve.
Yep, which additive manufacturing technologies are already working on making human organs, which is an insane thing to be able to say.
You beat me to the punch. It's almost like we planned this. Now, but that's where you're talking about actually getting into like cybernetics, right? Or is that even a word?
Another thing. Yeah, cybernetics, yeah. But like that's even another thing because, where we're at right now, we can print like actual fleshy biological organs the same way we print hamburgers or whatever. And cyber technology is also a solution, right? That's a different solution. That's instead of trying to make copies of what nature has done, maybe we can make it better. Maybe we can make hearts and lungs that will last longer, work harder, lighter, faster.
But I mean, you could have a 3D printed AI organ.
You absolutely could, and I'm sure at least one exists already. I'm sure of it.
I recall running into a gentleman once at a bar of all places who opened up a briefcase and showed me a robotic hand that he had developed for a client. So it wasn't quite AI, but it was a robot, and it was a full-on. I mean, it was a flesh hand. Yeah,
fingers, yeah,
the whole deal. And I mean, it was a wild place for this to occur. But I mean, this is pre-pandemic, and my mind was blown because you're talking about being able to develop something that is like plug and play to the human body.
And we're right on the edge of that being like feasible. We're constantly working on research in like machine interaction devices, headbands you put on that allow you to move a mouse cursor for people with disabilities who don't have use of their arms. We don't think about that segment of society a lot, right? People who can't interact with a phone or a TV or a computer in the way that we think is the normal way. But we're figuring out solutions for that all the time. And those things apply even beyond that, because it turns out if you can move a mouse cursor with your brain, that's useful for everybody.
Well, this is really gamification we're talking about now. Because when you start to, and I'm not even joking, right? Because you start to talk about this from the medical field, and you're like, okay, if you know how to run a joystick, you know what I mean? If a kid's good at gaming, that could be the jumping off. I mean, and I'm just thinking of entry points, and gamification has come a long way as it is. But when you're talking about some of the stuff you're talking about, I mean, it literally is. I mean, robotics, the input, the information, you have to drive it. Something's got to drive it. I mean, it's no different than playing a video game.
Well, yeah, to a point in that, during the Iraqi invasion and everything, when we were sending people out to Afghanistan, the U.S., I believe it was the Marines, their EOD teams, they spent like $7 or $8 million developing a high-tech control solution for these EOD robots, right? And then the rates of adoption among the soldiers were pretty low. People weren't liking it. They couldn't figure it out. And then one guy was like, why don't we just buy Xbox controllers? And all of a sudden, the rates of passing those classes shot through the roof, almost 100%, because people all of a sudden knew exactly what they were supposed to be doing.
Just change the I/O.
Yep.
That was the difference between computer space and Pong. It was the I/O. That was the only reason computer space wasn't known as the first video game, even though it was the first arcade game.
That's true. And you know what? And Pong went really far using a tool that wasn't fit for purpose.
And they're still using it.
Yep.
Well, now you say that. Say that again. Pong went really far using a tool that wasn't intended for that purpose.
Yeah, with the dial for moving. Like, if you think about one of the sort of limiting factors of interacting with all digital mediums is that we're kind of forced into doing the way it's hard to think of a solution nobody's thought of yet. Like, we still use desktop-based interfaces because the first person who invented the computer said, well, it's like working at a desk, so let's make it work like a desk. But that's not the best way to solve that problem. It's absolutely not. We just haven't figured out what the best way is. We're still using tools that aren't really fit for purpose. In the same way that I mentioned with humanoid robots earlier, like, people are really excited because we're building these humanoid robots to go and do these things that we currently have to do. But we're not fit for these purposes, and we're really close to having the ability to make things that are, to design cars that are specifically engineered to be as safe and efficient as possible, not just to be something humans can use reasonably. Once that's out of the equation, a lot of stuff gets better. Once you don't have to interact with it in a way limited by what we understand and what we can do, that opens up the possibility space a lot.
But once that train leaves the station, I mean, now that's where you start to get into the dystopian stuff. And we're talking about all the benefits and all these fantastic opportunities. But let's talk for a minute about some of the downsides, because once a physical something, because at that point it's not even a machine, it's an artificial being. But once it has that kind of information where it can think and reason on its own, I mean, that is opening Pandora's box for some really heady sci-fi stuff.
It really is. And like, we always talk about technology as if progress implies an increase, like as if progress implies goodness, but it doesn't. Like you're saying, there is the possibility for things to go wrong.
Well, that's the cause and effect of anything in life, whether people realize it or not.
Yes, progress does not imply improvement, I guess. Sometimes we might take a step back. Sometimes we might realize that something we thought was better is worse for us.
Correct. Yeah.
And it's important for us as humans to be vigilant and make sure that we are doing what's best for us as a whole, not just what works best for one company or one group of people or one individual.
Well, yeah, so you have Robotis is working with MIT, and that's backed by the South Korean government, right? And everyone's trying to do their thing. And now you got some guy in his garage, right? The next Steve Jobs, whomever, Steve Wozniak, let's be fair. And he's going too far, too fast. So we're talking a lot about innovation. We're talking, about all these different positive effects, and we're talking about standardization. But what about regulation?
Well, and that's a really hard question to answer. Like, there are so many little aspects that can be considered. The fact that regulation is also written by people who don't necessarily understand what you're regulating is a problem in itself.
We have that problem right now with Congress and social media.
Yeah, and it's a fair point. Like how there's a big difference between even having advisors telling you what things are and understanding it yourself. And there's only so much you can do on that, you know?
You have to be poised to react because it will be that kid in the garage. It will be the next Steve Wozniak that goes too far too fast, and the companies are racing to catch up.
Yeah, and people are talking about, we've been talking a lot about AI today. And that's one of the sort of scary things about AI too, is that we know that sort of the upper bound for this is something that is so smart it will make us look dumb.
Right.
And we don't think we're there yet, but there's also the possibility that we might not know when we are, and
Right.
that in itself is scary.
Well, that's where I'm talking. I mean, there was that kid a few months ago who was like 11 years old and did the crypto pump and dump. You know what I'm talking about?
I hadn't heard about that, but so easy, even a kid can do it, huh?
Well, right. So we got these 11-year-olds, out there outpacing anything most adults can understand. That was the moment when I was like, I wouldn't even know how to have bought that if I wanted to. So that I stopped to educate myself, because when I feel like things are going too fast, I want to learn. And I just feel like that's the Wild West all over again, man. Some kid in his bedroom, some kid in the garage is gonna build a robot, and then we're all gonna be freaking out. Kid builds RoboCop.
That makes me think of one of my favorite. I'm a skateboarder, have been my whole life, and one of my favorite lessons, or like lessons that I teach people when they learn how to skateboard, bike, school, whatever, is the first lesson: never go faster than you know how to stop. And right now, we don't know how fast we can stop. We have no clue.
But a company like Robotis, working with an institution like MIT, is poised to at least have some self-regulation.
Yeah, we're trying to figure out where, we're on this specific project, we're trying to stay far away from that cliff.
Yeah.
But we want, we're going to have an idea of, hey, maybe this is stuff we shouldn't be messing with yet. Maybe this is something that's unsafe. And that's an important safeguard that every company needs to have.
I'm fascinated about the smart cities. For me, because going back to the Disney of it all, and Epcot and the original idea for Progress City, and I look around this country, and we are so behind with smart cities. There are other countries that have already abandoned smart cities, and we haven't even tried it yet. Like, they're already like, no, that one didn't work, on to the next. And I'm fascinated where and that's kind of where I made the correlation to the Internet of Things, because to me, the physical implementation of AI to the point that it just becomes ingrained in your everyday appliances, something like that. To me, a smart city that would be able to regulate, I don't know, the temperature of the entire city, whatever we're talking about. I think of that, and I'm like, we are so behind on developing anything in that realm. And yet Walt Disney was trying to do it back then.
Yeah, that's the saddest thing that we never got to witness. I would have loved to see what Epcot would have been in its true, real vision. That would have been amazing.
But that's what I'm saying. So this is a little pie in the sky, but somebody's got a dream. The land is there, right? A company like Robotis paired with MIT goes to a company like Disney and says, hey, we want to fund something. You have the land. I look at all these companies now embracing live work. Like, I just wish we had a visionary. I feel like we don't have a visionary that would run with something like that. And I think it's wild that Walt Disney wanted to build the city of tomorrow when nobody was thinking about it, and we still haven't even scratched the surface. And that's what scares me in terms of the larger race against all these other countries, to not just be sustainable and to exist, but to actually to lead and to actually have the educational system in place to actually set these kids up, these future generations, to be competitive with China and Japan. We're not.
And one of the things that is sort of inherent in smart cities is they're going to be so much more efficient than we have now, right? There's going to be so many hidden benefits we can't even notice. People, every so often, the sort of consensus discussion starts talking about overpopulation, right? There's so many people, the world's going to collapse, we're going to run out of resources. But if you do the math, Actually, if we all lived in the population density of Tokyo, which is not the most density in the world, and by and large has a pretty good standard of living, right? We would all fit within 500,000 miles. And think about how much extra space there is for, leisure areas, for food growth, for all of that. Like, we are not currently using all of our resources that we have.
Right.
For many reasons. And we can do a lot better if we set our mind to it. And smart cities is a good step in that direction.
Yeah, I would love, and listen, I would love to see the return of the World's Fair. I think that would be the beginning of that.
Yeah.
Companies like Robotis can lead the way. I mean, you're talking about physical AI and all of these things. And I'm just looking at it from the perspective of like most of these kids these days are like crying because they're going to lose TikTok. Somebody said to me today, her daughter was upset because if she has to watch Instagram or if she has to watch YouTube shorts, she'll be 3 months behind everybody on TikTok on the rest of the world. I'm like, this is what the kids are worried about. She's like, I don't want to be one of those kids, Mom. And I'm like, the kids watching the Chinese version of TikTok are getting Steam and STEM fed to them every second they scroll. I know it's a rant. You don't have to say anything. It just drives me crazy.
Yeah, I mean, so I've never been a social media person.
Yeah.
I still don't. So that's something that I'm not the target market.
I get it. But you understand what I'm saying, and that goes to the point of making these things accessible to kids. I mean, it's not that hard to get into robotics. Most kids at this point know what a Raspberry Pi or an Arduino is.
Yeah, I mean, I got my start with Lego and put things together, make a move. That's all you need if you want to get started in something like this. Just try stuff out.
So what does Robotis offer for kids? I like to say kids of all ages. What does Robotis offer for kids of all ages in terms of just getting into the world of robotics? I'll even use the term animatronics because all the theme park kids, it's the same thing.
Yeah.
It's the same thing.
Yeah, really.
So talk to me a little bit about points of entry for beginners, for maybe the more advanced mindset.
Yeah, sure. So I guess starting at the lowest end, we have what we call our OLO educational kits, and they're basically it helps to have a little bit of background. As we've mentioned, we're a Korean company, Robotis, and one of the big differences between Korea and a lot of other places in the world is that they like after school programs are a huge part of the educational market. So these kits were designed specifically for like classroom educational after school settings where you have, 4 or 5 kids working together as a team with a teacher sort of going through it. So they're projects that are specifically designed to be fun to complete as a group, to work together. They encourage you to sort of speak with other people, talk solutions out, and find collaborative solutions. So they're a little different from most robotics kits, right? The angle is a little different because it's more about teamwork than necessarily about the project itself. But then from there, you move on up to, we have a couple of Steam Cup like robots that kind of bridge the gap between those Olo kits. They're a little simpler in construction. They're like snap together parts and things like that with 1 or 2 motors. And the next step up would be we have sort of small humanoid robots and things in that nature, the TIG, RG, and I believe there's a little robot with a car called Kodala. And those, they focus a little bit more on programming concepts because when you're starting at a younger age, that's really the most important thing, learning how to think like a robotics programmer, because that's something we as people don't do often. It's learning to program and learning to think in a way like a computer or a robot would think is very different from how humans do it. So the earlier you get a start on that, the bigger difference it makes.
Now, is this all proprietary stuff, like little proprietary ladder programming, or is it Arduino driven?
We have off the shelf, all of our kits and stuff are designed for, we have something similar to like Blockly and Scratch, block-based programming. So it's a little easier for the kids to understand. But since this is the stage where the parts start being our fully featured, industrial actuators, just the small ones. So they're also perfectly open to like low-level programming, Python, write out the commands, do whatever you want. That's also an option. So that if you're, maybe an overachiever when you're little, you can start off with the off the shelf, lessons or whatever. And once you get bored of that, you can say, okay, now I'm going to go crazy. And then from there, you just move on up to, we have a couple of sort of intermediate kits like our engineer kit. And these are just our full size actuators with a couple of lessons and plans, teaching you advanced programming, things like that. But at this point, you're basically building a robot from scratch, right? It's the same technology, same capabilities you would be using in high-end research or in industry. And the idea of all of these things put together is so that, if you're a parent who wants to get your kid into this, or if, you're a kid who just finds something interesting at a young age, you can pick a kit, figure out how it works, and then stick with it, grow all the way up until you get to university or, industry level.
Yeah.
And there's not a break where you have to say, oh, everything I've learned before this is now useless. I have to relearn.
Right.
There's never that discontinuity, so that your lessons constantly build up on each other. And I think that's something that's kind of lacking in a lot of robotics education. There's usually, the entry level kit, and then you get to Arduino, and there's a break between those two things.
Sure.
Where you have to learn a new skill set. And then once you finish with Arduino, there's a break when you have to go into industry.
I hadn't thought about it like that. So when you talk about that, does that lead into some of the larger things, robotic? I know it's not going to lead into the AI, the physical AI and all of that, but does
really kind of.
Does it really?
Yeah.
Okay.
We have some kits that are specifically designed. We partnered with, I mentioned Hugging Face before, to offer, hopefully soon, straight off the shelf to your home, a small robotic arm kit designed for at-home physical AI.
Yeah, I need a Jarvis. Like, that's the coolest thing ever. Like, I just want to have a Jarvis, like, on my kitchen counter. Just be like, Jarvis, hand me my coffee. Even though it's, like, right there.
You're going to have him move your coffee further away so that then he can hand it back.
I'm just testing. That's all. It's just research and development. It's like when we used to fix arcade games. We never played them. We only tested them.
That's the fun part.
I will. I'll make sure to get some links from you just to drop some stuff down for some of this that you've described. I'm surprised to hear that. So that's really cool. The idea that it's you can kind of keep building and growing with it, and then actually it'll lead you into actually having the knowledge to enter into the workforce. I mean, you're not going to have a degree, but you're actually working in the same sandbox that you folks are actually developing in for the future.
Exactly. That's it. That's the best way to put it. The same sandbox. Every time the sandbox gets a little bit bigger until you're eventually playing on the same beach as everyone else.
It's a lot of fun.
That's the goal. I mean, it's important, right? If we want kids to start learning early, you've got to make it fun. If you want adults to start learning, you want to make it fun.
Well, that's the other side of it, too. And that's why I kind of joke and I say kids of all ages. But YouTube University is amazing. And I don't think it's too late for people to be getting into a new field, especially something like this, because it's not going to matter your age or your work history. What's going to matter is what you know.
Yeah, and then specifically, if any of you out there listening are interested in getting in robotics, there are open source master's level robotics courses available all over GitHub, university websites. If there's a school that you've always wanted to attend, I guarantee if you just look up, whatever that school name, online curriculum, they probably have many on fully complete courses available online for you to take at your own pace.
Love that. I appreciate your time. I'm looking at the clock here. When I first met you at IAPA, we've talked about a lot of different things. So is there anything in relation to the company that you guys are doing, or is there anything just that you want to bring up that maybe we haven't touched on because it wasn't applicable related to Robotis as a whole?
I mean, the thing that I am most proud of and most excited, I've mentioned it, this is going to be the third time now, is that little small at-home training, the Coach 1v1 robot arm kit, because that's what I believe is going to be the future of robotics.
Well, I'm excited about it too.
Yeah, but it's bringing it to everybody. It's cheap, easy, understandable. It allows everybody to participate, which means it's breaking down social barriers, economic barriers, locational barriers. because robotics is and should be for everyone.
Listen, and I'm not just saying I'm excited because I want one. I would get those little arms that would do like the hobby servos. So it would be like a claw arm. You know what I'm talking about? A very
Yeah.
rudimentary version. And you can't do anything with it.
They had some at like I totally blanked on the name.
But you can get it for like $25 on Amazon.
Yeah, just like simple.
But how are you going to control like seriously? You're going to control 3 servos at the same time to make that actually grab something? Like it's not
Armatron.
What do you mean?
It's called the Armatron, the original of those.
Oh, is
They're
it?
like little, Armatron.
Okay.
Came out in like the 80s. Little, yeah.
Yeah. So I'm just saying, so like that's just a gimmick because you can't actually do anything with it.
Yeah.
You know, I'm not going to actually, what am I going to sit there with and move 3 actuators but you're actually now talking about like the future is now, not to be cliche about it, but like we're literally talking about something that won't just do it, but it'll learn as it does it.
Yep, it'll learn, it'll get better. There's been a couple of videos actually on YouTube University where some people have been teaching their children how to use this and like going through how to teach their children how to work with AI. And that's insane, right? That's amazing.
So
that's the next generation.
What was the model number you just dropped on that?
Oh, the Coach V1.1 robot arm. That's one of the links I'll be sure to share with you as well.
But are they all considered open manipulator?
That one is not part of the open manipulator series.
Okay.
The open manipulator, we have the X, the P, and the Y. The X is probably the one that it's closest to that Coach arm, but it's a little more expensive than the Coach arm. It's right about with a level I'd consider unreasonable to expect everyone to get one.
Sure.
It's almost $1,000, $2,000.
But what makes something open manipulator versus not open manipulator?
The open manipulator is our, like, we call it a reference platform, but it's our standard, like developed by Robotis for the public.
Okay. So that is what you're in theory working on when you talk to companies like NVIDIA and you go, let's develop something that we can all work with together. That's your lane.
Say, here are the off-the-shelf varieties.
Yeah.
Point at, is what you need between this and this? Yeah. Then we will narrow it down and get something perfect for you.
And then we'll all succeed, and then we'll all compete and go back to our walled gardens.
Exactly. As is the way of technology.
But it's funny just to bring it back to the theme parks, and this is such a trite kind of thing that people say, but they often talk about Universal and Disney competing. And I'm like, you do understand that they're in a shared market. Like they have a vested interest in the market succeeding as a whole. There's no real competition. Any competition in the market is just to breed innovation. It's all healthy.
Yeah, to call back to something that maybe some younger roboticists might be familiar with, cooperation. You might be working against each other, but you're also working with each other.
Right.
Like you're making each other better at every possible moment.
But that's only to the benefit of really to the consumer, because if there's not a standard, then, we're left going, what do I get? An iPod or a Zune player? Not that everything should be an Apple walled garden product, but I'm just saying, like, having a little thought and consideration for the consumer up front will go a long way.
Yep.
And we need that.
For the record, I'm Team Zune.
Say it again. I'm sorry.
For the record, I'm Team Zune.
Are you really?
Yeah.
Well, listen, that's I think you're about 20 years late with that argument.
I still had it up until last year.
Well, listen, I love my mini disc player. I don't use it, but it's over there. Okay.
Fair enough.
And you know what's just to get really geeky? Mini disc had two different lives.
Yeah.
Mini disc came out. And it came out as a stereo component, and then it disappeared and came back as a portable thing, and then they went digital with it.
I had the portable mini disc player for a while when I was a kid. That was my thing.
It's just out of reach, or I'd show it to you. And by the way, it's sitting there with like every Game Boy. By the way, it's just stuff from my old business. I just found this box the other day, and I used to have a display case. It's like the history of every Game Boy in order.
Ooh.
So I just love that stuff. You think about that stuff though, and a lot of it came from a lack of cooperation. Not to get super geeky, but I think of Tetris. I mean, if you know your history, those guys stole a video game. And the next thing you know, you had Nintendo and Sega suing each other over something neither one of them owned. You know, so we've come a long way in terms of cooperation.
And we still have a long way to go yet.
Well, I appreciate your time. Thank you. I think you and I could talk about a lot of things. It's nice to talk to people that have a shared spirit of all of this, you know?
Well, hopefully we'll get to talk again some other time.
Right? Yeah, I think so. And if there are other folks at Robotis or whatever you want to, because to me, and I'll just leave us with this, we have to start really, like, STEAM and STEM is a nice flashy term, but we really just have to start educating our youth. And we have to start.
It should be a special thing. It should just be education.
It drives me nuts. And then on top of that, they couldn't decide. Right? You couldn't just say STEAM or STEM. Like, you were so indecisive about it. Now we got a slash in the middle. Like, come on. Like, how many conversion? Like, come on. Least path of resistance here.
I mean, we still haven't even moved over to the metric system, which.
I mean, listen, what do you want? The Zune player or the metric system? You only get one. Sophie's choice.
All right, fine. Metric system.
Oh, I thought you would have gone with the Zune player. I'm shocked.
I've been thinking about getting an iPod.
Again, you're 20 years late. Listen, I remember getting the touchscreen BlackBerry when the iPhone first came out because I wanted to be the resistance, and that I wound up throwing it against the wall and getting an iPhone.
Yeah, if one thing Apple does well, it's make things very fun and easy to use.
Well, Apple's become a glorified consumer products company. You know, they're not the Apple of Steve and Steve. You know, but I will say, you know, you talk about Disney, you talk about Apple. These guys had a huge impact on our culture, and I don't think people even realize the relationship between people like Steve Jobs, Steve Wozniak, Nolan Bushnell, George Lucas, you know, Pixar, all of that. Like, there's a connected tissue through technology that most people aren't educated on, and it's really fascinating if you take a look at it.
The high ends of technology, you know, the ends of the future, it's a small circle, right? Everybody knows everybody.
Nolan Bushnell was offered to invest in Apple for $50K. He turned it down. I think it was a third of Apple for $50K. And he's like, no, we're busy. Jonathan, thank you so much. We'll talk soon.